Now we have discussed centrifugal pump, positive displacement. What is the difference now? You see, and example of positive displacement pump like diaphragm pump. Diaphragm pump it will be like this. I have one diaphragm here. Okay, using one rod. Okay, I can have using rod this diaphragm. So if diaphragm is moving up and down, then fluid will be sucked or delivered. So you can make certain valve arrangement so they can deliver. So many cases diaphragm pump also being used. Reciprocating pump. Reciprocating pump will have like piston, okay, and you can have one valve here, and fluid can be sucked, it can be delivered. Okay, this is reciprocating pump continuously, like cycle pumper. You are delivering continuously certain amount of fluid. So they call reciprocating pump. This is diaphragm pump. Progressive cavity pump I have already shown from my bag. Screw pump. Screw pump is actually one type of progressive cavity pump. There is another vane pump is there. There will be scroll pump. Many types of positive displacement pumps are there. Okay. And positive displacement pump again, it can be like simplex pump, duplex pump, triplex, multi-cylinder, single acting, double acting. So many type of pumps will be there. Okay. So reciprocating pump, whenever I told like cycle pumper, I already have shown one picture of this People Live movie, hand pump, rural household people will be using. So reciprocating pump is you are giving reciprocating force to one piston. Okay, let's say I have one piston here, and you are giving reciprocating force alternating. Okay, and there will be one certain valve arrangement. Using that valve arrangement, actually you suck fluid from one point and you deliver fluid to another point. Okay, when piston will be moving backward, maybe you are sucking. When piston pushing down, this is called piston. This is piston rod. Okay, this is cylinder. This is suction pipe. This is delivery pipe. Delivery pipe. Okay, so whenever we are moving up and down, suction pipe will be sucking fluid, delivery pipe will be delivering. Okay, and suction side one valve will be there. During upstroke only it will be opening. When downstroke, suction valve will be closed, delivery valve will be open. Okay, so that way reciprocating type pump will be working. This is called single acting reciprocating pump. Okay, and another pump can be possible like double acting pump. How double acting pump will be working? Yes, I will be making a horizontal one pump, and I have one piston again. Piston will be very thin gap, almost no gap actually. Okay, and this is my piston rod, and I have one suction pipe, I have a delivery pipe, and this side also I will have similar arrangement. Okay, like this. Okay, so in single acting reciprocating pump, you had only one time delivering, one time sucking, but in double acting pump, you say A, B. You see A side actually single acting pump, and when piston is moving backward, when let's say A1, A2, A3, A4, when piston is moving backward, let's say A1 to A3, right side is moving. So cavity A is getting filled, but cavity B it will be delivering fluid. Okay. Again, when it is moving opposite direction, B will be sucking, A will be delivering. So continuously, one will be cylinder will be filled, another cylinder will be delivering fluid. So that is called double acting. So when piston moving left side or right side, both ways it is sucking or delivering. But in single acting case, it is delivering only during one stroke, other stroke it is sucking. Okay. So, double acting cylinder, this is double acting pump. Double acting I should write reciprocating. Okay. So, single acting pump, if I have, how much fluid it can deliver? So, piston's diameter, let us say diameter D, okay, cylinder diameter D. So, in that case, what is the area of the piston? Area of piston equals pi by 4 d square, okay. And how much stroke length? How much from top to bottom it is going? This stroke length is L. Okay, L. So, volume A into L, total volume delivering, let us say area and total length. So, total volume delivering in one time. And what is the flow rate then? A, L, N. N means number of stroke. Number of strokes. Okay, how many number of stroke? 1, 2, 3. In 1 minute, they say 60 is doing. So, 60 into total volume delivering. So, that is the flow rate. Okay. But for double acting, so Q will be doubled. Q doubled. So, it will be like Q will be 2ALN. But another issue is there. You see, B side actually rod volume also there. Presently, I am ignoring the rod volume. If I consider rod volume, piston rod volume, then rod volume you have to do minus, right. So, Q will be like ALN plus area is reduced now, area minus area rod LN. Okay. So, this much of volume will be delivered in two double acting reciprocating pump. But if you have single acting, this is single acting. Okay. But if you assume that piston rod is very thin and it will not take lots of volume, so you can ignore. So, you can see one problem, single acting formula Ln, double acting 2Ln, ignoring connecting rod diameter, discharge meter cube. So, unit or SI unit, water delivered per stroke, L is length. So, in a double acting reciprocating pump, if the area of piston 200, so first you draw piston, right, it is like this, right, 200 centimeter area, 200, length of stroke 15, okay, crank rotation 60 rpm, N is giving 60. So, for double acting, so 2 into 0.15 into 0.02 into 60, so it is giving 0.35. If efficiency 98%, why efficiency coming up? Because piston and cylinder we are assuming ideally there is no gap, but there might be certain amount of gap, like piston and cylinder, you see this one, small amount of gap may be possible. So, there may be certain amount of leakage. So, if there is any leakage, then total volume whatever you are calculating, it cannot deliver that much, there will be a little bit lower volume. Okay. So, that is then your total efficiency will total volume flow rate will be like 0.343. Okay. So, another problem is here, a single acting reciprocating pump delivering water 0.018 meter cube, runs 60 rpm, stroke length 500, piston diameter 200, total piston diameter is given, okay, total lift is 15 meter. So, total fluid lift. So, theoretical head Q theoretical ALN by 60, so pi by 4 d square into NL by 60. So it is coming pi by 4 into 0.22 square 0.5 into 60 by 60. So it is giving 0.019 meter cube per second. So slip Q theoretical minus Q actual equals 0.019 minus 0.018 equals 0.001 meter cube per second. So slip percentage 0.001 by 0.018 into 100 equals 5.26 percentage. So CD okay, slip formula actually I should write Q theoretical minus Q actual divided by Q actual, Q theoretical. So CD equals Q actual by Q theoretical equals 0.018 divided 0.019 equals 947. So P theoretical power rho Q theoretical into GHST neglect losses. Okay, so it is coming like 1000 into 0.019 into 9.81 into 15. It is giving 2796 watt equals 2.8 watt. So motor efficiency if motor efficiency is 95%, then electric input input equals 2.8 divided by 95 equals 2.95 watt kilowatt. Okay, so theoretical power output running the pump. Okay, electrical input also we got.